Hello and welcome to another video. Come for the education, but please stay for the motivation. Today's video is a continuation of our series on cracking the coding interview, and today we're solving a problem which we've solved in the past called loop detection. Feel free to pause the video to read through what the problem is asking for, but I actually find examples a lot more descriptive. Also keep in mind that this happens to be a LeetCode problem, again, which we've solved before using a hash set, but a hash set has O of n space, which is not that good, so we want to solve it using O of 1 space. Again, I believe the condition for solving it using O of 1, okay, is right here. Follow up, can you solve it using O of 1 memory? So which is what we're going to attempt to do today. So again, just to go through the example, given a linked list A, B, C, D, C, where this C is the exact same as this C, is not just a new different C, right? We want to return that node that loops back around, in this case C. So a second example in this case can be 1 2 3 4 2. You see how this 4 connects this 2 and it loops back around, so we want to return that node that cycles, okay, 4 or 2, to be honest, just know where the cycle is, detect the cycle. Before we solve this, our motivation for today comes from Muhammad Ali, and I quote, "What keeps me going is goals." I feel like in life you need to have goals. If you're watching this video, you probably have a lot of goals. You need to have daily goals, weekly goals, monthly goals, yearly goals, goals for your life, goals for your family, goals for your happiness. Because if you don't have goals, there's nothing to chase after. You have no reason to keep on going in life. Think of not having goals like asking Steph Curry to make a free throw, but there's no rim. Yeah, you take out the rim and give him, hey, go make a free throw. It's impossible. It's easier to hit a target you can't see, that's blindfolding Steph Curry and ask him to take a free throw, than it is to hit a target you don't have. And that's the case where you take the goalie away and ask Steph Curry to make a free throw. So always have goals in life. So back to the problem. So here's how we're gonna solve it. We're gonna define a function, def, and I'm gonna call him hasLoop. You can call him whatever you want, whatever makes you happy, but this function takes in the head of the loop, of the linked list, and then we're going to do the meats and potatoes inside this function. So first thing I want to do is I want to create 2 pointers. This is a 2-pointer method. So typically it's called the runner method, which is the second hint we have here, using a fast and a slow pointer. So I'm going to create the first one, a slow and a fast, and initially I'm going to assign both of them to the head of our list. So in our linked list, this is what it looks like. We're going to have 2 pointers here, a slow and a second pointer of fast, pointing to the head of the linked list. Then we're going to use the while loop. The intention is our slow is going to move 1 step. For every 1 step our slow pointer moves, our fast moves 2 steps. So we need to make sure there's enough elements in the list for where our fast can take 2 steps. And how we do that is saying a while loop, while, fast, and fast. The next. This is making sure we can take 2 steps for our fast. Okay, so then in this while loop, we're going to take 2 steps. We're going to first move our slow. Okay, he moves by 1 step, so he equals to slow dot next. Fast, on the other hand, moves by 2 steps. Dot next. Dot next. And then once we do this, once we move both of them, we want to check, hey, does slow happen to be equal to fast? This is just a way of saying, is slow and fast pointing to the exact same item in our linked list? Okay, if this is the case, that is obviously going to be the item to return, so we just go ahead and return that item. In this case, you can choose to either return slow or fast, so I'm just going to say fast, because at this point, if it goes into the if loop, it means they are equal. Okay, so without further ado, let's walk through this function and see what it does. So in the first iteration, okay, we've created slow and fast, put them to the head. Next, we're in a while loop to iterate through this linked list. So next, we're going to move slow. First, for each 1 step slow takes, remember slow moves to this guy. Fast is going to have to take 2 steps. So first 1 step, then 2 steps. Okay, so at this point, after this first iteration, our slow and fast pointers are now in this position respectively. Slow is right here. Fast, on the other hand, is right here. Then we're going to check, are slow and fast equal to each other? Nope, they're not equal. Slow points to 2, fast points to 3. So we're just going to go back to the top of a while loop again, and we're going to move slow and fast. Again, slow moves by 1. Each 1 movement slow makes, fast moves by 2. So fast is going to move first, and then he's going to move second. So now after the second iteration, slow and fast. Slow is now where fast is, and fast is now where slow is technically, because he moved around. So I'm just gonna go ahead and show what that is. Then we go and check again. Are slow and fast pointing to the same node? Nope, they're still pointing to two different nodes, right? So we're just gonna go back to the top of our loop and move slow and fast again. Slow moves by 1. For every 1 he moves, fast moves twice because he's a fast dude. Okay, then at the end of this third iteration of our loop, keep in mind that now fast and slow point to the exact same person, right? Okay, so now we're gonna do the check again. Is fast and slow equal? Yeah, they're equal, so we'll return fast or slow. So we technically return this node. This is our node where the cycle starts. So let's see what it looks like on our code editor. So I've gone ahead and created our node class, which is the building block of our linked list. Created the linked list class, created the append function, which is how we append values to our linked list. Created the append node function, which is how we append nodes once we're given a node to the linked list. Created the display function outside of the class, right, which is how we visualize our linked list. And this is the exact same function we just edited on the whiteboard. Okay, so I've created my node. This is my node 2. Okay, I gave him a weird value of 9994 just because I can. Okay, and I created my linked list. 1 points to node 2, points to node 3, node 4, then. So once you run this, it's gonna give you the repeating node, which is this guy. So let's go ahead and run it. Okay, it gives us this guy. If you want to see his value, you can do a dot value right here, and you should see his value. But let's also take it back to LeetCode. Like I said, this is a LeetCode problem, exact same solution. Okay, I'm returning fast, but you can choose to return slow. So let's go ahead and submit this code and see how we do. Boom, we passed. So that's it for the video, guys. I hope it was helpful and educative, and I'll see you in the next one.